Today, starting with, kind of chapter 2, could have easily started with this day 1 right out of the gates. What is chemistry? But instead, we're going to save it for chapter 2. Chapter 2 is going to be a little different, a lot more terms, things like that. Less math than before, so some of you will like that. This may be a little more like biology in terms of kind of remembering those terms. Starting with the definition of chemistry, it's the study of matter and its properties and the changes it undergoes. Hopefully review in terms of what matter is. If not, we'll get to it in a second. But chemistry answers questions like, what is this substance? What's it made of? How much of each of those things is in it? It's this percent of oxygen type question. What are its properties? So it's shiny, it's acidic, it dissolves this substance type. How much is there? And then how can it be made? And then even what's it useful for? Chemistry answers a lot of questions. There's a lot of good applications of chemistry, and hopefully you'll pick up on that. So we alluded to it a second ago. Matter, anything that has mass or takes up space, which we call volume. Definition of mass, it's the measure of the amount of material in an object. Different from weight. That's more of a physics class question, but it is different. And then the last part here, volume, we talked about it, how much space something occupies. These next few boards are kind of color-coded here, but we're going to talk about two types of matter. The first one is pure substances, the other one mixtures. All of the pure substance stuff is in blue. So pure substances, this is where it's the same stuff throughout. Think about those pictures in the POGIL activity. If we've gotten there, you can see this picture, everything's the same in it. And it's circles all throughout, or it's circles bonded to squares all throughout. So same stuff. There are two types of pure substances. The first is an element. So simplest kind of matter cannot be broken down and still have properties of that element. If you do start breaking these things down, that's where you get things like protons and neutrons and electrons that we'll get to. Elements made up of only one type. So if I have the element oxygen, the only atoms that are going to be in there are oxygen atoms, where an atom is just the smallest particle of an element. So it's one piece. The second type of pure substance is compounds. So these are made of two or more atoms of different elements chemically combined together. So this is carbon and oxygen together. This is nitrogen and oxygen together, sodium and chlorine together, things like that. When broken down, the pieces, those atoms, have completely different properties than the compound. I give the example of rust. Rust is iron oxide. It's iron and oxygen mixed together. Rust, very brittle. It's orange in color. Whereas, if you think about just the iron itself, iron, very strong metal. When you bend it, well, it is bend. You can bend it. You can mold it. It doesn't break. It's malleable. Is the word I was looking for. And it's shiny, grayish black in color. Where the rust is definitely a different color. And oxygen, you can't even see it. But in the form of rust, you see that orange color. The second type of matter then is mixtures. We just talked about pure substances here. Mixtures, these are physical blends. Those pure substances, especially those compounds, people get compounds and mixtures mixed up. Compounds are chemical bonds. Mixtures are physical blends. They're not actually physically attached to each other, where each part keeps its own property. get to some examples here and bring back these, but the first, we have two types: heterogeneous, where hetero means different, so these look different throughout. You look at one part versus the other versus another, and it looks different, so not uniform in composition. Think about a salad. You have the cheese, you have the carrots, you have the tomatoes, and the lettuce. I could take one bite where I get mostly carrots and cheese. Take another bite, I get a tomato, a little bit of lettuce, and some carrots. Each bite isn't the same. It looks different, especially if you look at it from the side. You probably have lettuce on the bottom and then the toppings on the top. Same thing with chocolate chip cookie. I can see the cookie part versus the chocolate chip part, and they taste different. So that's where that hetero part comes in. It's different throughout. The other kind of mixture then is homogeneous, where homo meaning same, so same composition throughout. You look at these things and no matter if you look at the top, middle, bottom, wherever, it looks the same. So we call these, sometimes we call them solutions, so also known as solutions. These will never settle out. Where I used to teach, the previous chemistry teacher made some Kool-Aid, and this year, August 26th, that Kool-Aid would have turned 22 years old. So older than most of you, but if you were to look at it, it would be the same from the day it was made. So it never settled, and it still looks the same on the top, the bottom, anywhere throughout. Most solutions consist of one or more substances dissolved, called solutes. So in that Kool-Aid, I think the sugar was dissolved in there, the Kool-Aid particles were dissolved in there. In a liquid called a solvent. In the Kool-Aid's case, that solvent is water. Just a side note, water is called the universal solvent, which means a lot of things dissolve in water. Not everything, but a lot of things. And the reason why these things never settle, the reason why this Kool-Aid that I keep talking about looks the same today, is because the particle sizes are so close together that they don't work their way past each other and then just stay. So like the bigger particles just don't fall to the bottom. They're just continuously being mixed around. Examples, we talked about Kool-Aid, salt water, kind of the same thing. Where air, if you look around, you can't see the nitrogen versus the oxygen versus the carbon dioxide versus kind of the other gases in there. It all looks the same. If not, that would be weird world we live in. The other one is alloys. For those of you that play softball, for those of you baseball, your bike, things like that, a lot of things are made of alloys. If you were to cut that apart, you wouldn't be able to see the aluminum versus the chromium versus the nickel. So alloys are considered solutions as well, except they're solids, where here we had gases. Most of the time, though, we think of them as liquids.